is here with us to discuss what they have to offer to our portfolios regarding AI-assisted controls and optimization within smart buildings. Given the direction that we've all been taking toward intelligent and efficient building operations, this technology could provide greater insight into improved performance, energy reduction targets, and our sustainable operating practices that should enhance the longevity and functionality of the buildings in our regions. So just as a quick reminder to our attendees that this is a webinar being recorded for future reference. We will be posting it to the company's YouTube channel for internal circulation. And we also request that you leave your microphones on mute during the presentation. But should you have any questions or comments to ask of Trane, we will be accepting all of them at the end during our Q&A period. So Julie is also on hand as well to take notes for anyone who's raising their hand or who has submitted their comments to the chat on the video. So without further ado, Mike or Lincoln?
You want to? Yeah, let me get started here, and then Lincoln, I will hand it over to you. All right, here we go. Just want to confirm that everyone can see the screen there. Just going to throw that into presentation mode. All right, hopefully everyone sees just the Trane and not the speaker screen.
Good.
Yep, we're good. All right, Lincoln, over to you.
You've been driving.
Yeah, okay, go for it.
Okay, thank you everyone for the invite today. I'm Lincoln from Trane, and I'm here with Mike from BrainBox AI, and we're here to share some of our latest innovations in building optimization. So next.
Yep.
So BGIS and Trane we've been working together for many years, pretty much at the core asset level, chillers, equipment, and offering service on our equipment as well. Not too much on the connectivity and the controls layer yet, which is fine. Trane's been around for 113 years. Started as a low pressure steam control heating system with convectors. 88 years ago, we innovated into cooling with our turbo core chiller. Our centrifugal chiller is 75 years old this year. Our control line came out 45 years ago. And our digital intelligence started about 10 years ago with analytic clouds. And our latest acquisition is BrainBox AI. So this digital intelligence core help our customers with their business outcomes, uptime, energy savings, decarb, whatever your KPIs are, we will help with our digital intelligence. And we're found in every vertical market across the industry. Next slide.
Mm-hmm.
So where are you in your digital journey, data journey? It's all about data. So back in the 1980s, we were replacing pneumatic controls, no data, right? Just a pressure gauge was our data. DDC controls come out, direct digital control. Oh, we had a bit of data. Data was limited to a PC, small PC in a mechanical room. We added modems at one point. Alarms could go out, and then we could dial in. Once again, limited data to look back and help troubleshoot. Next. Fast forward to 10 years ago, we had our analytic cloud started. So all machine data goes to our analytic cloud, and all our building automation system data, right down to a VAV box, gets populated in the cloud. It does not have to be Trane equipment. It does not have to be Trane controls. Slide.
Mm-hmm.
And our latest offering is our AI-driven building from BrainBox. Okay, so traditionally control service and HVAC maintenance took a lot of knowledge and effort. With the limited data again, we usually come in, there was a log book in the boiler room, facility manager would have complaints, building operator complaints. The data came from our tenants, right? Too hot, too cold. We'd have to dig back through trending, alarm logs, spending a lot of time and effort just to find the problem on the control side, and the same thing on the HVAC side. Too hot, too cold, stuffy. We went to the roof and we started, right? A lot of time and effort.
Mm-hmm.
Next slide. Along came our analytic cloud on the control side. Now we're informed of the problem before we get there. It's flagging faults for us. Chilled water cycling, on the HVAC side, compressor failure, chillers, oil pressure, refrigerant loss, all there. Now we're there to fix the problem. And now the latest offering is AI-driven building, where AI actually controls the building 24/7, 365 on the control side. And then on the physical side, or the HVAC side, we have a virtual mechanical engineering agent that will help optimize and inform of any HVAC fixes. And Mike will go into more detail shortly on both these offerings. So back to connect. We need data to make our digital intelligence work. So we want to connect first. Next option is mechanical maintenance or control maintenance, all going to our analytic cloud. The next step where we want to get to with all our customers is optimization. So we use AI for real-time optimization of building energy and performance with our consultative approach. Okay, so it's all upfront strategy and action planning. What are your KPIs from that first slide? Your uptime, operational savings, decarb. What are we trying to do? Make sure we get the optimizations on the start working correctly. Understand which actions will help you meet your energy and system performance goals and milestone targets. Next slide. We call it the Trane or consultative approach. What do you want to achieve? What metrics are important to you? We collect the relevant data and information and what's it telling us, and we sit down and consult. Slide. And goes back to those KPIs, decarb, reduce energy consumption, utility rebates, whatever KPI you're trying to achieve, we got the digital intelligence to help. So Trane's a sustainable thermal solutions partner. That's what we are. From our equipment to our digital intelligence. So with that, one-stop shop.
Yep.
And with that, I'll turn it over to Mike.
All right. Sounds good. Thanks, Lincoln. So yeah, talking about AI buildings and what that looks like today. Quick recap, or I guess quick overview of BrainBox AI and Trane. Of course, this is all one Trane solution. A bit of a background on BrainBox AI. We are a built in Canada, made in Canada solution. We continue to be BrainBox AI's lab continues to be headquartered in Montreal. And of course, we are a part of the Trane family, supporting their offerings and expanding their capabilities. Now, when we say AI, I mean, AI is a buzzword. It's everywhere today. So what I want to do is just break down what exactly is BrainBox doing and how do you get to this AI for buildings thing. Lincoln actually touched on an interesting thing, because the first step to get to an AI building or an autonomous building is the connection side, the integration piece, right? This tends to be the most challenging bit, especially if you're dealing with disparate control systems, disparate labeling parameters for the buildings, and of course, different asset classes. That's kind of step one for what we're doing for what AI control is. How do you get to an AI building? Normalize the data. Once you have that stabilized connection, you can then get to a point where you're understanding how the building is operating, understanding how its operations change based on a number of different parameters. With that, you are then able to autonomously optimize HVAC operations for multiple objectives, anything from energy efficiency, comfort, decarbonization, and of course, equipment health across all those different vectors. And then, of course, with that data, you now have something, you now can layer onto the power where you have says virtual energy engineer, but a virtual building agent that can actually support the operation side of things. So save you time, make each truck roll more effective, help you service the problem pieces of equipment instead of spending time on a wild goose chase effectively. So zooming in on how we get to this autonomous control. First, like I mentioned, we're integrating to the building, spending a few months learning how the building operates in different conditions. How does the sun angle impact space temperature? How does the clothing people wear impact perceptions of comfort? All these different things, trying to understand how each building is acting, but also at scale. This can be done simultaneously across hundreds, potentially thousands of buildings. BrainBox AI currently is in 20, BrainBox AI or Trane AI control is in 20,000 buildings globally. So we're able to do this at scale. With that, we are then able to forecast the thermal behavior in each room up to 6 hours ahead of time with a 95% accuracy. If we're talking about AI, this is kind of where the machine learning and the core aspect of it comes in. With that high accuracy prediction, we're actually able to detect, okay, based on the current set of operating parameters, what is the thermal behavior going to do 6 hours ahead of time? If we predict that that thermal behavior is going to be outside a set of parameters, great. We can make that change right now and make sure that that doesn't happen. It's basic. Another way to visualize this cycle, start off by learning all of these different parameters, occupant levels, grid emission factors. We look at marginal emissions factors as well, the building data, utility tariffs, you name it. We then funnel that into a prediction engine, which continues to, like I said, predict the thermal behavior of a building at up to 6 hours ahead of time. That prediction is then compared with the actual output, and then that is used to fine tune the specific prediction model for that specific building. Once we get to a high degree of confidence that our predictions are accurate for that building, we're then able to act. And this cycle now repeats itself where our actions are able to change the parameters of the building, what's it doing, and it continues to improve over time. These changes and these micro adjustments to the HVAC system are done every 5 minutes to make sure you are staying within your comfort bounds. What this looks like, so this is a bit of a octopus or squid chart, if you want to call it. What we are doing at time equals 0 is running through a set of different permutations on if we want to stay within, you'll see there's the red line on top, blue line on top, hot and cold set points. If we want to stay within those set points at T equals 2 hours, what are the different things we need to do? It's running through all these different computations simultaneously and then almost plotting the optimal course to make sure that you're staying within those comfort bounds while also conserving energy and reducing equipment wear. Now, that's just one example. What does this look like from an energy standpoint? This is an example building, an energy profile before AI control from about 5 a.m. to 10 p.m. in the startup, right? You can see there's a decent amount of spikes. This is before we have been engaged. After our algorithms learn and engaged, you can see there's quite a dramatic difference. Couple of things to note here. First, the specific energy use for a piece of equipment is much tighter. So instead of activating 2 stages immediately or turning the fan to full speed ahead, our algorithm modulates to make sure that we are maintaining comfort while reducing, again, the fan wear, the equipment wear and tear, but also the energy usage. The other thing to note, if you look at the scales on before and after AI control, it only spikes at about 30 kilowatts during the startup. Before AI control, we're at 45 kilowatts there. So the scale difference is dramatic, and this is where the energy savings really start coming into play, in addition to the other benefits of equipment wear and tear. And again, these adjustments are being made every 5 minutes based on our learning models. So it is being done quite quickly. Now, I mentioned a virtual building agent or virtual engineer assistant using the data that we have. What we have created, because of course it wouldn't be an AI company without a large language model, is we have created an LLM that is specific to the built environment. This effectively allows technicians and energy managers, sustainability managers to talk to a building. So instead of getting a comfort complaint, running through the trend logs, trying to identify what piece of equipment is faulty, going through probably 45 minutes of work to identify what a potential issue might be, you just ask ARIA. You just say, I have a comfort complaint at this building. Can you investigate? And ARIA will go through the operations of the building, identify what the problem areas are, or even tell you if you're on a wild goose chase saying, hey, this is a one-off, no need to roll a truck, saving you time. It can even identify what parts you need, the specific procedures for a piece of equipment. This is ingesting everything, the building operational data, equipment IOM manuals, and specific processes for that equipment. I'll note here, just because it's a concern with large language models on the cyber piece. This model is based on Amazon Bedrock. It is not like a ChatGPT or Claude wrapper. This is not, each instance is not open to the internet. The data is not being cross-mingled across different customers or even across buildings in your portfolio. It is all kept very secure, and the training information is kept very tight to the specific operational parameters of the buildings, which also reduces hallucinations or eliminates them almost entirely. And so what we've also done in Montreal, if anyone is around, we have the first HVAC AI lab in the world. It's a bit of a mouthful, the BrainBox AI Trane Technologies AI lab and showroom in Montreal. But it is actually quite impressive. There's actually one article which we can send around after that describes it quite nicely. I touched AI and it didn't bite. And one key tidbit from that piece is, look, this tool is not it's not out to replace jobs. What it's here to do is replace guesswork and give back something that we all have a limited amount of time, whether it's eliminating the need to constantly monitor the BMS or, the guesswork and time associated with trying to identify a root cause in an HVAC unit. That's fundamentally what we are trying to do here. I believe there may be a video here. Let me see if I'm trying to see if I may have not shared sound. Okay, I'm sharing sound now, so hopefully this works.
We will now declare our lab open.
And so with that, you can buy time. So start your digital journey today. And that's a bit about what Trane Technologies has to offer on the AI building side. So I want to leave plenty of time for questions because that was a pretty rapid fire overview, but yeah, open the floor.
That's excellent. Yeah. So what do we have here? We've got a good amount of participants here. I see Jean-Paul's got his hand up.
For the modeling you've done, how many did you have to add any points to the existing automation system?
So typically we work with typically we don't. What part of our onboarding process is integrating to the existing BMS and identifying and understanding what points there may be. We try to leverage the existing infrastructure to eliminate the need for any kind of capital upgrades. Now, if you do need to add any points or change the BMS, that's why our partnership with Trane Technologies is so excellent. But typically for an AI control or Trane AI control implementation, we leverage what's already on site. And happy to talk through about the different integration methods as needed.
And when you're doing this, do you need a naming convention, or can you, is it smart enough to pick it up on individual buildings, or do you have to customize everything by building?
So I hate to say it depends, but it depends. Part of a lot of it has to do with our onboarding process. So just to speak to that, our team would do the haystack tagging for the points. We would extract and see what is available, and then based on that, we either leverage automations to identify pieces of equipment, or we have a team that does the haystack tagging themselves. Now, for an individual building, that's the process. As we look at portfolios, and this is kind of where the power of scale comes in, as we start to see common naming conventions within an existing portfolio, we can then quickly accelerate that integration and onboarding process. But to answer your question, we take care of that onboarding, that naming convention tagging. Certainly, that's something that we look at.
Thank you.
There we go. I see a comment from Dan Goslin.
Hi, thank you for the presentation. I was wondering if you had experienced a difference in performance depending on the type of building and whether you had experienced knowledgeable operators in the building.
Yeah, I mean, short answer, yes. I'll be, being transparent. I think some of the early feedback, this was before BrainBox AI was acquired by Trane, is that the AI control kind of acted like a black box. So certainly if there was already an existing sophisticated energy management or operational program in there, sometime like in the early days, there would be, upfront, there'd be some conflict there. And usually that's kind of where our outcomes would be called into question, which is totally fair. How we have evolved since then is to really serve the multitude of building operators. So for AI control, for example, we now have created audit logs to ensure that the commands that are being sent are transparent, and that, of course, if it's also highly customizable, so that, depending on what your needs are and where the gaps are, we want to make sure we plug into those. Now, in terms of performance, there's a range. If we are dealing with a situation where there is perhaps not a dedicated facilities management team, I assume that's not the case here because that's what you all do for a living. Our impact can be quite material, especially if it's an old system that hasn't been recommissioned. The further out we get from that commissioning date, the larger the initial results might be. For teams where there are dedicated facilities staff, we can still find ways to save energy. There's no doubt about it. We make an assessment before we even engage as to how much we can save. But certainly in those instances, that's where the other offerings that's where like the virtual building agent ARIA becomes a lot more powerful, allowing those operators to focus on more critical items rather than chasing fires that might not be critical.
Go.
Thank you.
Hopefully that answered the question. I went on a bit of a tangent there.
Yeah, no, it's all good. It's our experience as well that, the different types of fault detection systems in a well-managed building have reduced impact. And when they do, it's usually the first year, and then it's hard to find additional benefits.
Yeah, 100%. And I think that's one thing to point out about the AI learning cycle is certainly the longer we are in a building, the more kind of improvements we can find. Obviously, they won't be as significant as year one, but we want to make sure that we are continuing to add value. And then, of course, we have a dedicated measurement and verification team that makes sure that we are directionally performing the way you want. But we also, again, want to make sure that we are being additive and not competitive with anything that is already being done on site.
Nice. We've got a comment here from Angelo as well, too.
Oh, perfect.
Angelo.
Hey, Lincoln, how's it going?
Hey, great.
Uh,
Thanks.
So I have a few questions. So Laura, just mute me if whenever you want me to stop. First question, is the data stored on site or where's it stored?
So our data currently is primarily stored in the cloud. We use AWS,
Okay.
but we can geolocate we can basically geolocate where the data is to make sure that it is within the appropriate region. But we've certainly had a few customers ask about on-prem solutions. To my knowledge, I don't know that we've done that. Primarily the cloud-based basically the cloud-based system allows us to be quite snappy and flexible and scalable. That said, we've gone through a number of different cybersecurity regimens, so happy to discuss any specific needs that might be relevant here.
That's good. Like I said, a few questions. So second one, the typical contract term, can we sign up for a year? Is it months? Is it how does it, just high level?
Yep. So high level, and like this is more with the Trane side, but from the BrainBox AI, typically our agreement is a 3-year term. That said, there is flexibility in the length depending on what the path to scalability is. That's kind of what we want to make sure that we are doing, is driving value at scale.
Exactly.
I would say that the minimum we typically do is 1 year, because that is the amount of data that is required to do a proper measurement and verification. So that's what we target. But again, we certainly flexible depending on your situation.
Yeah. Okay, so as I understand, you need some time at the beginning to upload the stuff to get it customized to the building. So that's why it's like, okay, you want us to do anything, a year. Okay, no, fair enough. But your preference or what you've seen is optimal is 3 years. The third question.
Optimal is 3 years. Yeah, correct.
Yeah. Does the data, so let's say we've got a 3-year term, and at the end of the 3 years, okay, thank you very much. We don't need you anymore. Does the data leave with BrainBox Trane, or does it stay with the client?
Fantastic question. Your data is yours. We leave, you get all the data.
Okay, so that has been a change. I'm glad to hear that, because we dealt with BrainBox a couple of years ago and that was not the case. So thank you. That's perfect. I'm getting a little bit into we have a lot of Trane chillers and their service contracts. Would you guys be interested in saying, hey, you know what, we can bolt on some sort of a BrainBox solution to an existing service contract? Are you open to that? Or it's like, no, we need to do the whole building?
Nope. 100%. That actually becomes quite valuable for us, because how that would operate is, if there's an existing Trane MSA or any kind of agreement, we'd obviously want to understand what the nature of that agreement is. But typically what we have done is it would basically be a Trane AI control agreement. And it would be bolted onto those existing terms and conditions. So if you already contracted with Trane, that actually makes the path to contracting quite a bit easier for our solution. It would just be known as Trane AI Control, and it would be under their umbrella, which is, of course, the goal of this conversation as well.
Exactly.
Thank you. That sounds good. One last question, and this one, maybe Mike's going to mute me. How would you compare to, let's say, an EcoPilot or a Thermalio that's in Montreal? It's not a loaded question, but like how, but obviously I'm asking you why should we go with you guys compared to them?
To EcoPilot, and you mentioned one more.
Thermalio. So this is a company in Montreal that is similar in what I see is similar to BrainBox.
Yep. And I mean, that's a fair question. Obviously, I'm not going to disparage either of them. They're both fantastic companies, right? What I'll speak to is what we view as our differentiator, right? I think actually the slide that maybe that I'm not on the right slide there. Hold one moment. What I will do here, just make sure I'm on the right slide. Okay, perfect. I'll actually go up something that I think illustrates one of the larger advantages there, because, optimization is optimization. I'm sure there's people that can figure out what we do, right? What I think the core considerations are for us is we are the only AI company that has the backing of a company like Trane. So this slide here really highlights that BrainBox AI, yes, we have our algorithms, but then there's also the tie-in with Trane, which means we're going to be around. We're not going away anywhere. We're going to be around. So enterprise grade backing with startup level agility. We also have the ARIA AI agent, which is something I don't believe either of those others have, but it is a value add for consideration. The second piece to talk to is proven enterprise grade scaled. We're in over 20,000 buildings globally, and we continue to optimize those. So there's that enterprise grade capability. And then of course, there's the economics. We want to make sure there's an ROI, there's a positive ROI outcome within a reasonable time frame, usually within a year. I'm sure those others say that, but it's worth mentioning here. So to summarize, I mean,
yeah. No, that's good. No, thank you. You've answered my question. Thank you.
Yep.
Okay. We've got another one coming from Jean-Paul again.
Your programming, is it local or is it cloud-based?
Our programming is cloud-based.
Okay, and does it supersede the existing automation system? So if you want a supplier temperature of 15 and it's saying 18, what happens?
Right. Yeah, that's a fair question. We do not override the underlying programming of the BMS. I'm not the most technical person, but basically what I understand is we sit within the priority array kind of as an override. So how you will see BrainBox AI control, again, this is Trane AI control, but I use BrainBox and that interchangeably. How you will see us operating is as an override on the existing BMS. So it's very transparent in that way. That said, say you throw us out, or for some reason or another, you want us to disengage. I'll add that, for our customers, we do provide kill switches. So in case there needs to be maintenance done, you can disengage us, no questions asked. The system would revert to the original BMS programming. And we do that just to make, yep.
So you're programming, if the system's saying it wants a supplier of 18 and your analytics say, no, it should be 15, you override the programming. So you basically take remote control of the building systems off of the existing BAS. Okay.
Yeah, we pull set point levers and schedule levers. Those are the two most common levers. Yeah.
And the other thing with your sorry.
Yeah, at any point you can release it. It's right there in the priority array being overridden. You'll see BBAI is controlling discharge air set point of air handler 17. You don't like it, just remove it or override it.
Okay. And do you put a JACE or anything else on the front end, or you just talk BACnet to everybody?
So yeah, that speaks the integration piece. Depends on the system. If you're looking at a Tritium Niagara JACE, we would write a jar. It's a software only integration. We would write a jar file to be able to communicate to that specific control system. For a BACnet system, we would look at adding a gateway just to help us communicate those BACnet signal up to our cloud. So we would necessarily install a JACE, but like in the worst case, we install a gateway, but it's just to allow us to communicate.
All right. And the last one is, do you have a a manual point between the analytics discovering an issue and informing the client? Is there anybody that's doing triage on it to make sure that they are actual issues?
Yeah, so there's a few ways that we approach this. First, we have a team that monitors our algorithms and the performance of the algorithms to identify whether there are any potential issues there. So, for example, I was just talking with our team about a customer site where there was an RTU that would be firing both heating stages, but for some reason the room kept on dropping to 13 to 15 Celsius. That becomes a bit of an issue. So we basically flag that and say, hey, there's a potential issue here. Investigate it. That's one aspect of it. The second layer, and I don't know, Lincoln, and whether this is Ensemble or Cloud BMS, there is kind of a cloud level BMS that we have that includes a logic builder. This basically allows you to program custom alerting and alarming logic to make sure that you are getting the right alerts at the right time and triages them automatically based on your business rules. We also have the ability, there's also the ability to basically prioritize each of those kinds of alerts and send them to the appropriate people based on the alert type, the criticality, and a few other factors there. So that's the second piece. And then, of course, the third bit is with the AI agent Aria. If you're at a building and you say, hey, I'm at CD how are these chillers performing, or how is this building performing? It'll go through the pieces of equipment and say, hey, this RTU has been firing on all cylinders, but nothing's happening with the system. You should probably check that out. That last one is done based on prompting. So like you actually have to prompt it to get the potential issue. On the roadmap is the more proactive piece where it's like, hey, there's something going on with this, you should check it out. That's the AI agent angle. We've also done things like active performance testing, where say there's a large portfolio of buildings, we would actually start to fire each unit individually during off hours to identify, hey, this unit might be having an issue. So there's a few different ways we approach it. Some ranging from we look at it, we flag an issue, to this is extremely automated and done at scale. So depending on what you're looking at, yeah, a few different ways.
I'd be interested in getting an actual project where you can show what was done and how effective it was.
Yeah, absolutely. In terms of
we got a case study that.
Yeah, absolutely. We have a few of those as well. The one kind of customer I was talking to, this is more on the functional performance testing. It's a named customer, but Dollar Tree. They had probably about, let's say, 600 locations. Each location had about 6 RTUs. Over the course of 3 days with our automated, basically because we were connected, we were able to test fire each individual unit during a shoulder season and off times to identify which units were the problem units and which ones required we're okay to go. So that's one example, but certainly happy to send you additional information.
Thank you.
Excellent. Do we have any further questions, or I'm sure that there are some people that, have further information that they would like to request as well too, but we can always reach out to Trane directly and ask for more information as well.
Absolutely.
There we go. Okay. Well, excellent. I appreciate everybody coming and taking the time to join us this afternoon, or for people on the West Coast as well too, your mornings. And we look forward